Today, we shall be discussing data frame, vector, array, and matrix. Now we're going to start with data frame, how to bind 2 or 3 data frames together. And this is where we're going to start. Cheers. Let's go with me.
Now the following R codes present to you the use of R bind and C bind. Like I said, we have done data frame. But in a situation whereby you are collecting some data, if you are collecting large data sets, ordinarily you cannot handle it all alone. You may have to distribute it among a number of data analysts. So let's take, for example, now that we have multiple data that have been created. You must have given them the format and tell them that, okay, in my work, I already have 5 columns. I have 5 columns representing 5 variables, and we have 1,000 rows or cases. Come to your R and you create your table, you create your data set. This is what you're going to have, for example. So the first person that created it has generated this. He has created a variable called, now in this case, now I'm going to use variables apparently, and then 5 variables, and then what do we have here? Yes, 5 variables and three cases. This is what we have here. So this is the data set. This is the data set of the data set 3. This is what we have here. So I'm going to run this session alone, and as I run that session alone, I also will be interested in viewing or print the data set. But in this case, I don't want to print on this screen. I would rather view, so that at least we can see it in a bigger environment. I arrived at that table. I ran this code, which is what I presented on the PowerPoint. And at the end of the day, I have this data set. So we are going to have 3 of these. 3 of these, because in my following slides as well, that is what I have in my following slides. This is for this one. Then this is another 2. So this is another 2. This is Kunle Adeola and Shefina. This is another one. This is Kakobola and Taju. Kakobola and Taju. So these are the 3 data sets I want to merge together, because I cannot work with them in isolation. I am supposed to merge these data sets and then move on with my work, so that I can merge these together and then do the analysis I want to perform. You cannot carry out the analysis separately, 50-50 in 8 places. No. You have to bring all the data sets together and then match them to do your analysis. Then how do we match? The R bind and the C bind will now come into play. Now, to match the data frames, you can either match them by row or match them by column. We're going to see the 2 together and demonstrate. These are the command, the function. To bind by row is R bind. It's called R bind. That's what I started with here. To bind by row is called R bind, meaning row bind. So to match those data sets or data frame by column, it is called column bind. I've created 3 data frames and I want to match them together. So that is to teach you how to do data frame, where you can have a person as a variable or a column in that your data frame. But in this case, we want to merge by row at first, in the first instance. So it is the row merge, such that you can see them a list from 1, 2, 3. That's the first 3. Then the next 3 will be 4, 5, 6, and the next 3 will be 7, 8, 9. And that is what we have done here. So once you use that your code, which is as given here as our row bind, R binder, that is my own name, which you already know. So R bind, row bind, data set 3, I want to bind my data set 4, data set 5. So what I'm doing here is all these data sets must be within the same page of your program. So you copy this one, you also paste these 2 as well. within that data set, and then you put this command as well, this other command here in it, and then once you run this command, this is what you're going to get. See, all those data sets now have been merged in a single file. Like I said, if you like, you can save this one on your file, or you can leave it as it is. So we have done row binding. We have matched it together by row. So if you want to match also together by column, such that when you match by column, it is going to be listing them the maximum row you are going to. Now, before then, let us look at the dimension of this hard binder, of this row binding. If you want to look at the dimension, what you can do is just do a dim of that your file name, which is 9 by 5. Obviously, you can see that in each of those data sets or data frame, there are three records. Initially there was record of Awoleye, Osunleke, and Mumina. If you look at this place, you have this record, the first data set here, Awoleye, Osunleke, and Mumina. So, but at the same time, you can also do column bind. The C bind is the function that you need to use to do your column bind, which is what you have here, C bind. Don't forget the names of the dataset 3, dataset 4, dataset 5. So you just put your C bind and you will see what your output will be. So I'm going to do that again now directly straight away in my R so that we can see the output. Good. Can you see my output now coming in columns, merging the files in columns? So the maximum row you have here, the first one is Awoleye, Osunleke, which is as given. And the next one, which is the second data frame, is Kunle, Adeola, and Shefinat. And the next one is Kako, Bola, and Taju, presenting them in that form. I think by now it is very clear that you understand the two ways by which you can merge your data sets. And that is what we have just achieved with those few slides. So now, if that is settled, because I still want us to touch other things, I want us to save vector, we know how to store, create vectors. We are generating 1 to 50 numbers stored in a variable called Z. So I am generating 1 to 50 numbers, which will be presented in column as a vector. So 1 column 50. Once you press that, the next thing you are going to do is to now see your output, which is what will be presented here in your Z. So all you just have to do is just say that's your Z. But then it is better we view Z rather than just and that's our Z. From your end, I wanted to do it just now. Generate 50 to 100 numbers and store it in a place. Store it in a variable. Let's assume also now that you also want to add 2 to each of those numbers. You want to add a given number to each of those numbers. So you can also do something like the V plus 2. V plus 2. That's your output plus. So each of the numbers in those factors to add 2 marks to each of them. You can also say that let me find the mean of V. Get the mean of V to be 2. We're still going to experiment more about that, but then let's move on. So now other functions of vectors. If V, like I said, is a vector, like I said, you can also do mean. We have done mean. You want to know the maximum of that number. Just say max V. What is the maximum of that set of numbers within that vector? The maximum there is 3 because we have numbers 1 to 3. So, but then, like I also requested that we should store from 50 to 100. You have put it in your Z. Your Z is 50, generates numbers 50 to 100. Ordinarily from here, what will be our maximum number? Our max Z will now be 100. As simple as that. So you can also at the same time find the square root of that number, square root of V. sqrt of our v will generate that for each of the numbers in the factor. So you can always do the same. You want to know the length. What is the length of that v? The length is how many data sets, how many data points do we have in that vector? It is the length. Counting is 1, 2, 3, 4, 5. If you want to know, okay, if I ask you how many numbers do we have between between 11 and 44, can you say it offhand? No. But this is how to do it. From your computer, you just say computer generate numbers from 11 to 44. You just say 11 to 44 and then put that in a container, call it answer, and then say I want to know, call it answer 11 to 44 already generated. You want to see that list, this is what you're going to have. But then we are not bothered about the list, we are bothered about the count. How many numbers do we have between that set? So what you just have to say is length ans, and it will tell you we have 34 numbers. Like I said, also you can also calculate the sum of the first 100 numbers. Then how do you go about that? How do you calculate the sum of the first 100 numbers? I want you to tell me. And then you want to know the mean of the first 100 numbers. How do you go about that? You want to know the mean of the first 100 numbers. Okay, excellent, Mr. Ajibola Ojoawo. I like that. That's fantastic. That's generating. You have just generated the number. Yeah, fantastic. Excellent. But then your code will not run because there is a double quote at the beginning. So it should be single quotes. That's excellent. Thank you for doing that. That's a good one. So just generate 1 to 100. Then you find the mean. I know, I understand. That was excellent. So you just generate from 1 column 100 and it will give you that number. And then you can then put that number, the answer of that, in a column, in a variable. And then you can then find the mean of that. You can also find the square root of that. You can also, what about if you want to square that particular number? If I ask you to square the square, do this again. I want your participation now. Square the output of this set of numbers from 50 to 60. Somebody presented the answer in the chat room, but I apparently wanted him to do the square, not square root. Yeah, Mr. Iesulo, fantastic. No, but then you won't put your k inside brackets. Your k will not be inside brackets. You don't have to. You don't have to. Your k does not have to be inside brackets. So excellent, Mr. Ajibola. That should be excellent. If you remove your k inside bracket and then you put that concatenation response, fine. I am happy you are following. That means I've not been wasting my time. I'm happy to hear that. So let's move on. You may also wish to sort the numbers in decreasing value. When you want to sort your output in decreasing value, saying that excellent, yes. When you want to sort it in decreasing value, ordinarily before decreasing value, when you use the function sort my v, it will do the sorting for you by default in ascending order. I want to sort my v, that's my output. I want to sort my z. What do I have in my z? I think I have a series of numbers from 1 to 100. It's going to give me, okay, from 50 to 100, that's my z. But this time around, I want to sort it in decreasing value. All you have to do is sort at your variable. It is stored in z rather, comma, decreasing. To accept that and say my decreasing in this time around is true. And you run your output. You can see that it's starting from 100, 99, 98, 97, and so on and so forth. So that is what this command will do for you. Sort your data frame name and then decreasing value to be true. So the next thing now is to quickly see our array and matrices. It's also familiar, very close to what we have been doing. We already know. So you can create an array having this. This is an example of how to create an array. You want to create an array of 1 to 10 numbers. You want to create an array of 1 to 10 numbers. And then you want to order them. You want to arrange them in this order. In column, put them in column, 2 rows, 5 columns. That is what our C 2,5 is telling us. I want to generate 10 numbers from 1 to 10 and then arrange them such that I have them in rows, 2 rows, and then 5 columns. So let us do this. Array of how many numbers? 1 to 10 numbers. But then put them in 2,5. No, sorry. Two comma 5. Can you see that? So that is what you have. You cannot, don't forget, you can also put that in a variable name. But let's see. Now, if you look at the top here, you will see comma 1, comma 2, comma 3, comma 4, comma 5. That is the name of the columns. Down here to your left is 1 comma, is different from comma something. So the one to your left here is representing the rows, the cases. 1 comma 2, which means row 1, column 2. That is the location of that value 3. Figure 4 is in which location? You can speak or mute yourself and speak, or type it in the chat room. So while you are working on that, don't forget we are looking at how to generate arrays. Now, if you look at this number, I've generated 1 to 10 numbers, which means what is the length of 1 to 10 numbers? Let us see. What is the length of 1 to 10 numbers? Let me put this. Okay, let me just generate 1 to 10 numbers, 1 to 10. And I just want to know the length. Just to know the length. Let me call this J. So what's the length of J? Length of J is 10. So as you are specifying for your computer, for your R, to put them in columns and rows, it must be equal to the number that you generated. I'm going to come again. Now here you have specified generate 10 numbers. So that 10 numbers must be in an array in a matrix form, such that when you multiply 2 numbers together, it should give you the number, that the total number that you have generated. You have generated 10 numbers, and the array format should be 2 columns times 5 columns. I mean 2 rows times 5 columns. That gives us 10. If you say 2 comma 4, yes, it may run, but it will truncate the last 2 numbers, the remaining numbers. So in this case, I also want us to generate I think I have it in the next slide. Yeah, I also want to generate with another set of numbers. Let's say we want to generate 16 numbers from 4 to 16. 16 numbers from 4 to 16. You can also do it from your end, 4 to 16, 4 to 6. No, 4 to 16 is not 16 numbers. So let's say 1 to 16, so that at least that one is very obvious that it's 16 numbers. So in the same 2 rows, what will now be, how do we then, okay, in what ways can we arrange 16 numbers? In what matrix, in what form can we arrange these 16 numbers? I want to generate 16 numbers, call them 10. Let me just say 10 or okay, 16 in one. Thank you, my brother. 4 by 4. That's excellent. That's excellent. So 16. As you can either say 4 by 4. So that way, as you are creating your code, you are going to say array, create array of 1 to 16 numbers for me. Then set them 4 by 4. Set them in column, but then let it be in 4 by 4. 4 by 4. Yeah, that's what you have. This should run. I'm sure you can see my screen. Let me call it up and I run. You can see my 4 by 4 matrix. My 4 by 4 array. So if you look at that, you can also arrange it in another form. What other forms can you arrange these 16 numbers? What other forms, what other arrangements can you give to it? What other arrangements? What other formats? What other ways? In how many ways can you multiply? How else can you get 16?
2 by 8.
Thank you, 2 by 8 or 8 by 2. So let us do, we have this, let's say 2 by 8. So let's quickly do the matrix so that we can talk about a few other things as well. Matrix is a 2D array. It is a 2D array. It's comprised of array. So, but then there's a fast method of creating a matrix. By using that name straight away, use the matrix. The word matrix is a function. Just like replace the word matrix by array. I mean, replace the where we have used array, call it matrix. So, and then you can do the same thing like we have done for array, and you get your matrix. So, like I also said, you can get a matrix of 1 to 16. 16. I mean, fortunately, I've done it here. I've done it here. So I've done it here. So you can also do more than that. Let's do for 20. Can you generate array of numbers from 1 to 20 and then put them in 4 rows, 5 columns? 4 rows, 5 columns. 20 numbers. I'm just bringing that from my head now. 20 numbers from 20 numbers. You want to do 1 to 20 numbers, as simple as that, and then you are putting them in what? 4 by 5. As simple as you just see your output there. We're generating matrix. To replace it there, I think I want us to be 4 by 5. Put it inside 20. No, it's not 1 to 20. Put it in another name called 20. Okay, so I have my 20. That's my matrix. I have my matrix 4 by 5. I have my matrix 4 by 5 already. So the location 15 for 15 is referred to as what?
3 by 4.
Okay, 3 by 4. Excellent. Okay, so that is that. So very briefly, we are going to stop here tonight, and then this is the assignment for the week. Create a set of matrices of different figures and bind them together in 2 ways, using your row binding and your column binding. Then generate the first 1000 numbers in a given interval and perform some statistical in a given interval other than 1. So I did not tell you that, but it's simple. What to do is use the word seq as sequence. Okay, let me quickly assist you to generate. Let's just say, okay, B now. B, I want to generate 1 to 20. Seq is a function for sequence. Seq is a function for sequence. Is it answering me? Okay, so, and then you can see the use here, which time will not permit us. So I don't intend to bring it in tonight, but at least just to give you a hint of how to go about it. So from is equal to 1 to 1 and things like that. So you can see that and then experiment with it. So then generate the first 1,000 numbers in a given interval and perform some statistical analysis, like all this mean. You want to look at the maximum, you want to look at the length of the numbers, and all those ones we have used. You want to square it, you want to square root it, and things like that, and some other mathematical operations. So these are the two assignments you have for against next week. So we're stopping here tonight.